Hey guys, what's up everyone? Welcome or welcome back again to another video tutorial lesson from the AP3X Institute of Mathematics Education. My name is Akeen, your math instructor, and in today's video we're going to be looking at the application concepts related to the topic of bearings. All right, a very important topic. Now in previous tutorials you can find a link to my playlist, and links to those videos will be available in the description box below, where we had looked at some prerequisite formulas that you're going to not only know mentally, like you have to know the formula, but you have to know how to apply the formula when and where. So do check those videos out. Those would have been the Pythagorean theorem, sine, cosine, and tangent ratio. Most importantly, especially when it comes to a non-right angle triangle, is the application of the cosine and the sine rule. Now, assuming that you are equipped to utilizing those formulas effectively and you've watched those previous tutorials, then doing bearings is not going to be a very difficult task. So if this is the first time here on the channel, of course, please go ahead and turn on that notification bell and smash that subscribe button to be notified on a weekly basis whenever I post contents related to the CSEC, CCSLC, SEA, or just math in general, concepts related to math in general. All right, so go ahead and of course leave a like and help me to share this video out to your math groups and math communities. Okay, so here we go. We're gonna jump right into the video, and we're gonna be first starting off pardon me guys, I'm a little sick today, but we're gonna be starting off with the definition of what is a bearing. All right, and as you can see here on screen, that a bearing is basically the degree of measurement that aids in identifying the direction in which an object travels. All right, so usually whenever we're giving you a bearing, we're kind of indicating to you the direction in which the object is going to be traveling, and we're going to be using an estimation process. So no protractor is going to be needed, no precise pinpoint measurement is going to be needed. It's just an estimation of the direction that an object may be traveling. Now, one very important concept as it relates to bearing is that a bearing is measured in a clockwise direction, and we usually measure our bearing from north, and it's measured after the word that comes, or it's measured from the point that comes after the keyword from. Right, so whatever point comes after the word from in a given particular question, then usually that's where we measure our bearing from. All right guys, I want you to take some time out now, and I want you to tune into this video because it's going to be a lot of information being dispensed here, as well as we're going to be going through some technical questions that will seriously equip you to becoming very proficient at bearings application. All right, so next here that we're going to be looking at is that a bearing is merely an estimation, as we had mentioned before in the introduction, of a direction, and can easily be done using the 8 cardinal degree directional points. All right, and so these cardinal points that you see I have here on screen are just really guidelines. That's what I call them guidelines. These guidelines gives us a realistic estimation of where the object may be traveling. Now, we're not so much concerned about whether the object is going to be traveling north, northeast, east, southeast, southwest, west, or northwest. We're not really concerned about that, but these kind of gives us an idea of the direction that the object may be traveling. So if an object is traveling perhaps say 0 degree, then we expect that the object may be traveling north. 45 degree means the object will be traveling in between north and east, which naturally would have been northeast. If the object is traveling on a bearing of 90, usually we indicate this by saying that the object is traveling due east. All right, so you most time will hear us say in the question that the object is traveling due east. All right, you may hear due south, Of course, you may hear due west, and of course you may hear due north. So whenever you hear due north, due west, due east, due south, that usually indicates that the object is traveling on one of the four initial cardinal points. All the other degrees are degrees that go exactly between the four. So 135 would have been between east and south, 225 would have been between south and west, 315 would have been between west and north. All right, and so basically these guidelines kind of gives us a very good idea of where the object may be traveling. Now here are our 8 cardinal points here: north, west, east, and south. And so when it comes to constructing a bearing, guys, the step one here is that constructing a bearing is that we have to indicate a starting point on paper. All right, we have to indicate a starting point on the paper and insert a north line. Now, once an object is going to move, and this object could be a plane, it could be a ship, it could be a boat, this could be an object that's moving in a open space. Then once it's been suggested that the object is going to be moving, right, then you have to establish a north line. Now, if the object makes one movement and then it stops, and then the object makes another movement, then on the second movement, you also have to establish a north line again. Now, illustrate any necessary guidelines that may be used in the estimation to make it as realistic as possible. So we did say earlier that we have our 90 degrees, our 180 degrees, our 270 degrees. We have those guidelines. So I normally indicate those, as you're going to see in the examples, with broken lines, and I normally indicate my 4 standard cardinal points directions with bold lines. So it's going to be very important that we do that. Now, drawing a line in the direction of this estimation, and hence the bearing of the angle will be formed. All right, so whenever we have drawn that, then we are going to draw our bearing in a clockwise direction. All right, so just to put this into more perspective, let's look at some examples of how to structure the following angles of 60 degrees, 80 degrees, and 130. We're going to be doing it on here. Alright, so for the first example here, 60 degrees, I know that 60 degrees is obviously going to be less than 90, and I know it's going to be greater than 0 degrees, so it's going to be somewhere in between here. Now we've got to make it realistic, because we know already that here we would find that this here exactly between would have been 45 degrees. So right away I know that 60 degrees is going to be a little bit closer to 90 degrees than it would be to 0 degrees. So by estimation, I'm establishing here that it's around this direction here. And so my bearing is going to be my bearing is going to be in this direction here. All right, so here we're going to go like so and come around like that. Pardon me. Okay, all right guys, so we're just gonna come around like so, and we're gonna stop here. And so this angle in here is going to be 60 degree. Now we're gonna be, you see, with these little guidelines here that I've constructed here, then you're gonna find that later on when the questions becomes a little technical, then with these little guidelines we may be able to find angles like in here. Okay, so this angle perhaps would be about 15 degree, because the complete angle is 60 and our guideline here is 45, so in between here would have been about 15 degree. All right, so the guidelines are going to be very important when it comes to constructing a bearing. Let's have a look at the angle 80 degrees. Now already I know that 80 degrees is very close here to say for example 90 degrees. So once again I would just insert a little guideline here. So again, these little guidelines are going to be very, very important, guys. I emphasize this a lot with my students, that using these guidelines are important. Now we know that 80 degrees is really close to 90, so I'm knowing that it's around here in this direction. So remember that the bearing comes from north in a clockwise direction and comes around to the point that leads us to where our object is traveling. So it's around here. Okay, so all of this here, these two angles here would have been 80 degrees, and in between here now we know we could actually calculate that, because if all the angle is 80 degrees, then you're gonna find that if I subtract, say for example 45 degrees from 80, so if we say 80 take away 45, then you'll find here that our answer is going to be 35 degrees. So if we needed to calculate this little piece of angle in here, we could say that this angle here is 35 degree. All right. So hope you're catching on. All right, let's just run through a couple more examples so you can get a little comfortable with constructing the bearing. 130 degrees. Now that's really, really close to a halfway distance between 90 and 180. So I know here that here is 180 degrees, and I know that 135 degrees is exactly between 90 and here. So 130 is really, really close. I could say it's really, really close to here. So you could almost say that it's really 135 degrees. So this little piece of angle in here, so all the way around, coming like so, all the way around like this, would be 135 degree. All right, sorry, 130 degree. So if for whatever reason we needed to find this little piece of angle in here, then we know that this angle would have been 5 degree. All right, so remember, notice how we're drawing the bearing. It's always from north coming around to the line that's leading us to the direction that our object is traveling. 165 degree, once again, you can see here that we're going to be constructing a 135 degree here. So 165 now is going to be a little, is 165 naturally is going to be about 35 degree more than 135. Okay, so that's going to be very close here. So somewhere in this direction here. Okay. So in this direction, somewhere about there. All right, and so our bearing will come from north and come around like so, all the way around here. And so all of this angle 1, 2, 3 adds up to 165. So let's say for example, I know that this would have been, say for example, 90 degrees from north to east, and then all the way around here now would have been the remaining angle, which would have been here. So if you come all the way around here, this little piece of angle here would have been, say, 45 degree, and this little piece of angle here would have been, say for example, 35 degree. And if you wanted to find the remaining angle, then naturally this angle would have been about 15 degrees. So you can see how this one little guideline here helps us to cut off all the angles, and these little pieces of angles here is what's going to make the bearing or the calculation of bearings a little easier. All right, so what I want you guys to do for me now is to just practice to do the 215 degree, 245 degree, 300 degree, and let me know in the comment section how you feel about it. Of course, a link is in the description box below to my direct WhatsApp, so if you need to check with your answers, you can actually send screenshots to the link of my WhatsApp, and I will confirm if it is that you are indeed correct. All right, so let me know in the comment section how that goes, but hopefully you guys get a clear understanding that number one, a bearing is measured in a clockwise direction, and the bearing comes around from north to the line that's leading us to the direction that the object is traveling. And it's very, very important that you construct these little guidelines here, because it helps us to find these little incremental angles in between there. Okay, so Hopefully you got an understanding of that. Now we're gonna get really into the examples now. This is where the real application process comes in. All right, so here we go. So bearings application question. Now, a lot of the times you're gonna find that on more advanced examples like the ones I'm doing here is where you're the one that are expected to construct the diagram, but occasionally you might get an example where the diagram is constructed for you and you're the one that has to implement the angles inside the diagram. So hopefully we meet up on an example, but let's just take it one step at a time here and learn how to construct a complete diagram where an object may be making more than one movements. So here we're looking at the fact that a plane travels from point A, keyword here is from. All right, so a plane travels from point A to point B, which is 15 kilometers away on a bearing of 110 degree. So what I like to do, guys, is that rather than reading the entire question at the same time, I tend to always read the question in parts and then I start to construct that aspect of the diagram related to that piece of information. So I know that the object is traveling here, say from point A. So the object here is traveling from point A. All right. And so it's going towards point B. So I need to indicate a north line here. All right. And so it's going towards point B. Now, point B is the distance of point A to point B is 15, but to know where B is going to go, we are going on a bearing of 110. So we definitely need to know that, okay, 110 is greater than 90, so we need to implement our here guideline of 90 degrees. Okay, so you don't need to necessarily put the angle 90 degrees. We just establish that this is 90 degrees. And so we know that it's greater than 90, so we're going to need another guideline, which is going to be 180 degrees. Okay, so here is our south. So 110 we know is less than 135, so 110 is really close to 90 than it is to 180, so it's going to be an estimation of about in this direction here. Okay, and so we can put point B anywhere here, and that is point B. All right, and so this distance here is going to be 15 kilometers away. Okay, all right, good. So that piece of information is implemented. Next, it says here that the plane then decides to travel to point C. All right, so the plane then decides to travel to point C, which is a further 25 kilometers away on a bearing of 50 degree. So we're going to implement here a north line. And so 50 degree is a little bit past, well, it's less than 90, so we're definitely going to need here a guideline of 90 degrees. And so 50 degrees is almost in between, almost between 0 and 90. So it's not exactly between, just a little bit more, but just an estimation that it's going to be about here. Okay, all right. And so this is going to be 25 kilometers. All right, 25 kilometers. And so let's just make it a little steeper because I want to make the line a little bit more realistic. So here should be a little, this line should be a little longer than this one to make the diagram a little bit more realistic. All right, so we just establish that even though this is not exactly 50 degree, we just understand that the angle here, the bearing coming around like this, is 50 degrees. So here is going to be 25 kilometers. All right, and I did forget to implement our bearing of 110, so let's just do that now. So coming around from north all the way around here, all of that angle here, these two angles here will add up to, say for example, 150 degrees. Sorry, 110 degrees, pardon me. All right, and then this bearing here, we establish here that that is going to be 50 degree. All right, and this is, say for example here, point C. All right, and so including the return to point A, so we said that this was point A in the initial stage. Okay, so therefore then we can just construct a line leading us to C here. Okay, and this is our diagram that we have. All right, this is our diagram that we have. So now with us establishing this particular diagram here, we can look at the fact that now we have constructed our diagram here. All right, and this is an estimation of how the actual plane traveled. All right, so before I actually go into looking at the questions, what I encourage a lot of students to do is that you try to start up, find these little piece of angles if possible. Right, because that's going to make it a lot easier. If you try to go ahead and answer the questions immediately, then sometimes you might find it very difficult to find these little angles. And as I said, these guidelines are what kind of guides us. So what I like to do is just use a little geometry here and find these little angles inside, because that's what's going to help us. So we can start out by the fact that here, the bearing coming around all the way from A taking us to B is 110. So we would have established here that, all right, let's see here. All right, so we would have established here that all of this angle here is 110. Let's see. Okay, we would have known that from here to here is 90. From here to here, that's from north all the way to east here, would have been 90 degrees. So let's just use a different color ink to make an indication here. So all of this angle, including this little piece, these two little pieces here, would have been 90 degrees. All right, so we would also establish that this little piece of angle in here is going to be, say, 20 degrees. All right, so that kind of helps us later on. All right, and if we so happen to need this angle here, all right, this is going to be here, right, we would also know that the total angle from north to south is 180. So we would have known here that this angle here is going to be 70 degrees. All right, because this is going to be, say for example here, 110 from 180, that gives us 70 degrees. So these little pieces of angles here, they may come into play here later on, depending on the question that is being asked of us. All right, now I notice here that I have a partial angle inside the triangle, but I could actually find this angle right here, so I could find a complete angle inside. Okay, and so if we look at the concept of alternate angles, you'll realize that north is parallel to south. So we could actually create some sort of Z angle, as we would refer to it. So here we'd have like a little Z here. Here. Okay, so this 70 degree that we had initially calculated here can be now transferred here. So therefore gives us a total angle in between these two sides to be approximately 110 or 120 degrees. So let's just bear those little information in a moment. All right, so I do encourage that when you're doing the bearings, guys, you try to find these little pieces of angles. And as I said, without these guidelines, it would be near impossible for you to actually find these little pieces of angle. All right, so here we go. With the aid of a diagram, draw the plane's journey from point A to point C, including the return to point A. Next, they had asked us, we have already done that, so calculate the distance of the point A to the point C. So we need this distance from here to here. And so as you can see here, naturally that we're going to need to use the cosine rule. Now if we revisit that particular video that I had made, we had already said that given that a triangle contains two sides and the angle between the two sides, then cosine rule is going to be applicable here. All right, so we can just go across to this page here and we can actually find the cosine rule. So here we can go ahead and find here cosine rule to be c squared is equal to a squared plus b squared minus 2ab times the cosine of the angle between the two sides. So c in this case would have been obviously the side that we're looking for, which is going to be the distance of A to C, that's point A to point C, so that's AC squared. Let's just write it's a little bigger for you guys here. Okay, so we have C squared is equal to A squared plus B squared minus 2AB times the cosine of the angle between. So C squared is going to be AC squared, and that's going to be equal to 15 squared plus 25 squared minus 2 times 15 times 25 multiplied by the cosine of the angle, which we had calculated geometrically to be 120 degrees. Now AC squared here is going to be equal to 15 squared is 225 and 25 squared is 625, and so we can go on our calculators and 2 times 15 times 25, that's going to give us 750 multiplied by the cosine of the angle, which is 120, that gives us negative 0.5. So if we go ahead and we add 225 to 625, we're going to get that AC is equal to 850. And we're going to see negative multiplied by negative is a positive. And so 750 multiplied by 0.5, which is a half of 750, that's 375. So if we sum that to 850, then we're going to find that AC squared is equal to 1225. Therefore, AC is equal to the square root of 1225. And we're going to find that the distance of point A to point C is 35 kilometers. All right, so the distance here is 35 kilometers. Okay, nice little question there. All right, and as I had mentioned previously in my tutorials, that whenever it is that you calculate the value of anything on or related to the diagram, it helps to insert it onto the diagram, because then it gives the diagram a little bit more life in terms of seeing how else we can use more simplified methods to find other follow-up questions. Okay, now the next thing that we're looking for here is to determine the bearing of point A, or the bearing of point A, keyword here, from the point C. All right, now I don't have a lot of space here. All right, so I'm just going to kind of make an indent here, and let's just say that this is the point C. All right, let me just shift in this point here so I can get the space that I need. So I'm going to reinsert my north line here. And so when they say that they're looking for the bearing of point A to point C, what we're looking for is the bearing coming around from north all the way to the line. All right, all the way to the line. So here I'm going to come all around. So basically I have a north line here, if you can try to visualize. Okay, and so I will be looking for the bearing coming all the way around here, coming all the way around here, all the way coming back to A. All right, so it'll be like all the way here. This part that's missing around here, I'm going to put it here. Okay, and then I come all the way around here, right? Because that's how a bearing is measured from north. So from north coming all the way around here. Okay, all right. Now I would have already found quite a few of the angles already, because from north to south here would have been 180. So I would have needed this little piece of angle in here. I would have also needed this piece of angle in here. All right, so from north to south I would have already established that that is 180 degrees. So we already have a piece of our bearing, and that's going to be plus to this angle here inside here plus this angle here. Now we can actually find this angle again using a geometric principle known as the alternate angles. So once again, let me grab my green marker, and so you can see this north line here is going to be parallel to this newly constructed south line here. So this piece of angle here is going to be, say, 50 degree in here. So in here will be 50 degree because it's alternate to this angle. So now we have another piece of our bearing. All right, so we need now to calculate the angle inside here. Okay, we need to calculate this angle here. All right, now remember that the arrow here for 20 degrees, naturally some of you guys would have been caught by adding the 70 and the 50 and the 20 and taking it from 180 to get this. But remember that this little piece of angle in here has not been established. So we actually need to find that piece of angle inside there. Okay, so we are not able to find it because we don't have enough information to kind of inject in here. But what we can do though is that we can actually use the sine rule to help us. We could actually use the cosine rule again, because one of the criteria of a cosine rule is that if you have all three sides, then we could actually use the cosine rule. Now what I want you guys to do for me, and let me know and confirm with me in the comment section, I want you guys to apply the cosine rule to find this angle and let me know if you got the same result as if when I used the sine rule. But for the purpose of the video, I'm going to be using the sine rule to calculate this angle in here. Okay, so let's just revisit what the sine rule is. The sine rule states that the side is going to be divided by the sine of the angle facing that side is going to be equal to b divided by the sine of the angle facing that particular side. And you can definitely check a link in the description box below if you are not familiar with what the sine rule is. A video was just previously uploaded, so definitely you want to tune in to that. Now once again, when it comes to using the a and the b using the sine rule, as I said, it's just a constructed formula, right? But you can switch up the formula if you want. What you can do here is just kind of indicate what you'd like to call your A and your B. Now what I like to do here is that I want to call my 15 here small a. So the angle that is facing 15 is going to be big A. All right, that's the angle I'm looking for, and so therefore I can use this to be my B, and then the angle in between, or that's facing 35, is going to be my big B. Now the reason why I didn't use the 25 as my B is because I don't know the complete angle that's facing 25, so I have to just ignore that 25 there. All right, so therefore I know that A is going to be 15 and the angle facing A is going to be unknown, so that's 15 divided by the sine of the angle, which of course is going to be the bearing or partial bearing. So let's just call that A for now. And B is going to be 35, and the angle facing 35 is 120 degree. Okay, so therefore we can go on our calculators now and we'll have 15 divided by the sine of, obviously I don't know what that angle is, and that's going to be 35 divided by, if we go on our calculators and we check for the sine of 120, you're going to find easily that that is 0.8660. So we can divide here. We would have been familiar with how to apply the sine rule from the previous tutorial. So that's 15 divided by the sine of A is equal to 35 divided by 0.8660. So that gives us here 40.42 rounded off. 40.42 rounded off. Now when the unknown variable is at the denominator, then we swap position. So we'd have ended up with 15 divided by, say here, 40.42, and that's going to be equivalent to sine A. All right, and so naturally here we're going to find that 15 divided by 40.42, that gives us here that sine A is equal to 0.371. So to find the angle then, A would have been equal to sine inverse 0.371. So shift, we insert sine raised to the minus 1, 0.371, and that's equal to 21 degree, approximately rounded off to being 22 degree. All right, and that there completes our first example of how to apply the sine and cosine rule to our diagram. All right, so you can see that the question started off a little simple, and then it got a little, little gesture. But if you follow these little arrows and these little guidelines, and so you're gonna find that a lot of the times you're gonna find yourself really running through questions like these very, very effectively. So hopefully if you guys got a clear understanding, I'm going to be doing another example in this particular video, and then I'm going to be doing a part 2 for you. All right, so I want you guys to actually rewatch if it is that you're not clear on certain concepts, and then of course leave your comments, questions and suggestions down below. So if you have gotten clear understanding on this, do not forget to leave a like onto the video, and then of course go ahead and let's jump right into another example. So this is a little bit more information here. You can see that it asks a little bit more of us, so let's jump right into it. Now it says here that two boats left a port, harbor X, and they traveled to harbor Y and port harbor Z. All right, so two boats are leaving the same port, right, on a bearing of 120 and 210 degrees. Now I don't have any space here, so I'm gonna have to go to the other page and construct. Now, as I said to you before, you do not want to read all the information at once. It gets a little complicated, especially when you find math a little difficult. So what you want to do is that you want to kind of focus on this piece of information first. All right, once you can get this piece of information out of the way, then you're good to go. So let's go ahead and let us indicate our starting port here. All right, so our starting port here is going to be harbor X. We can just put it right in the center of our paper here, and this is going to be harbor X. All right, let's just drag it down a little bit here, guys, because we're going to need some space for our bearing. Okay, so let's go here, let's bring it down here. All right, so that's harbor X. All right, so what is it saying here? That and it traveled to harbor Y, and it also traveled to harbor Z. So Y first, Z separate. So the bearing of Y from X is 120. Let's do that part first. So we're going to indicate our north line here. Okay, one north line is going to be required simply because both boats are leaving the same port. So we know that 120 is greater than 90. So we're going to need a guideline of 90 degrees here. And 120 is in between 90 and 180. So we're going to need another guideline here. Okay, so 120 is really close to 90. is less than 135, so it's not going to be exactly between. It's going to be about here. All right, and this is harbor Y. Remember that this is harbor X. Okay, and the bearing is 120. So we're going to go around here and indicate our 120. So from north, come around here is 120. So these two pieces of angles here that are constructed because of the guideline is equal to 120. So let's just indicate that that is 120 degrees. Okay, now another boat, let's just come here. Another boat, it says here, it leaves to go to harbor Z on a bearing of 210. So here we already established our knot line. So we already have our knot line, so let's just come around with a different color. Yeah. So we need another guideline, guys, because 210 is going to be in between 180 and 270. So we can insert here another guideline. That's going to be our 270 degree. And we can come all the way around here from north. Let's just do this with a different color ink. Make sure that we separate both bearing all the way around here. Now I want to notice that 210, remember that in between 180, this is 180, guys, and this is 270 degrees. Let's establish that first. So we know in between here would have been 225, so 210 is going to be maybe here in this direction. So here 210 about here. Okay, so coming all the way around here is going to be 210. So let's just indicate this with a little line here. Don't want to put too much markings here, guys, but you can see here that this blue line here is 210 degrees. So let's just indicate that right here. Okay, all right, so we have our two directions that we're traveling. Let's just overlap this line here with black. That is our harbor Y. Now, I'm not sure. Let me just go back and read the question to see if they gave us some distances, to see if it's drawn realistically. So the distance of Port Harbor Y and Z. So Y is first, Z second, Y is 35, Z 68. So therefore, this line would have been a little longer. So let's just make it a tad longer. Okay, all right. So this would have been 68 kilometers. And this would have been, this line here would have been 35. So we want to try to make the diagram as realistic. It makes no sense to draw this line here shorter than this one, because this line is in fact shorter in terms of dimension than this one. Okay, so we would have something like that. That is the diagram here. All right, so let's see what they have said here. It says, with the aid of a diagram, draw the routes that the boats travel to their individual ports. And this here would be, this here, as you see on screen, would have been a constructed diagram of how the boats would have been traveling. Now, before even looking at what is required or what is asked of us here, all right, we're gonna insert some little angles in here that we can use geometry to help us. All right, now the first thing I did establish here, guys, that the bearing from north, this black bearing here coming all the way around, is 120. We have indicated it here, and we know that this guideline here is 90 degrees. This is established that here, so that's 90 degrees. All right, so I know right in this little piece of angle here, let's just zoom it up here, this would have been naturally going to be 30 degrees. All right, because the full bearing is 120 and this aspect, this cut, this guideline here is 90, so the remaining angle would have been 30. All right, and we already established that this blue bearing coming all the way around here is in fact 210. So I could find this little piece of angle in here. We know that this is 180. This guideline chops the 210. Okay, so this here would have been, say for example, 30 degrees. All right, we could also find this little piece of angle in here also, right? Because here the angle coming around here is 120, and so obviously if you were to continue to come around here, that would have been 180. So right in this little piece of angle here is 60 degrees, and you can see again it proves that this 30 and this 60 actually makes this 90 degrees here. All right, can we find any more pieces of angle that may be useful to us? Can we? I think we've found all that we need, because up here would have naturally been again another 90 degrees. So we have found those little pieces of angle. Let's find this one around here in the event that we may need it. I'm not sure, but we know that coming all the way around from blue, coming around is 210 degrees, and this is 270. So in here would have been again 60 degrees. And as I said to you guys, when we find these little pieces of angles inside here, it's going to make later on it easier for us to calculate depending on what they're asking us. All right, so this is going to be XY and this is point Z. All right, and so there we have a nicely constructed diagram which would have given us about 3 marks, maybe 4, depending on the level or depending on the course that you're doing. Different marks are assigned to the difficult level of the question. Okay, so hopefully that's nice there for you. Next that we're going to be looking at now is to calculate the distance between Port Harbor Y and Port Harbor Z. So obviously there's not a line leading us there, so we're going to have to construct that distance here, and we're asked to calculate this distance. All right, so we don't have a lot of space, but we can make it. All right, so we're going to be using once again here the cosine rule, because as you can see here that we in fact have two sides and we have the angle between the two sides. And as I said to you before, had you not inserted these little pieces of angles in here, you would have to do it now, because then these two angles would have been missing. These two angles would have been missing. So therefore then we have calculated them prior, which makes the question a lot easier. Now we could perhaps use the cosine rule, but what I want to show you here, guys, is that a lot of the times we get caught up with using the cosine rule and the sine rule, that sometimes a question like this can be oblivious to us, because as you can see here that this is 60 and this is 30 degrees. So basically the angle, all right, let's just look carefully here, that the angle from this line here to this line here is 90. But notice that this angle here is 60 and this angle here is 30. So also this angle here, in fact, this angle here is actually at 90 degree. So, because 60 and 30 is 90. So what that means for us now is that we're not going to be using the cosine rule now. We're actually going to be using the Pythagorean theorem, because the diagram that we're looking at, we may not have been, it may not have been indicated in the initial stage that it would have been a right angle triangle, but based on the numerical values of the degree, then it works out that this here is 60 and this here is 90. So the diagram that we're looking at here is actually a right angled triangle. So that means then the cosine rule would not necessarily need to be applied here. You could use it if you want to, but it's a longer version when you could actually use the Pythagorean theorem. And so the Pythagorean theorem, as you can see here, is going to be c squared is equal to a squared plus b squared. All right, so hopefully you guys understand why I'm using the Pythagorean theorem, because it turns out that the diagram is a right angled triangle, and so C represents our hypotenuse, which is the side always facing the 90 degree. We have already established that. So this is going to be zy squared and that's going to be equal to 68 squared plus 35 squared. All right, so I'm going to go ahead here, and 68 squared That's 4,200, or pardon me, 4,624 plus 35 squared, 1,225, and that's going to be equal to zy squared. Okay, so zy squared is equal to, let's see here, 4,624, 5,849, 5,849. So zy then is equal to the root of 5,849, and that is equal to 76.5 kilometers rounded off. 76.5 kilometers rounded off. Okay, and that there basically gives us the distance of this line here. So this is 76.5 kilometers. All right, again, just to re-emphasize why I use the Pythagorean theorem as opposed to the cosine rule, which again, the cosine rule can be applied, but you're going to find that the cosine of 90 is 0, and so 0 multiplied by 2ab is going to be 0, which eliminates the formula down to c squared being equal to a squared plus b squared. But I mean, it's kind of irrelevant to use the cosine rule, but you're going to find that the latter half, let me show you here, that you're going to find that the latter half of the cosine rule, which would have been this aspect here, this aspect here would have been reduced to 0, because the cosine of 90 is 0, and 0 multiplied by 2ab is 0. So it would have just been left with c squared is equal to a squared plus b squared, which explains theoretically why we are using the Pythagorean theorem. All right, so hopefully you guys catch on to that particular example. All right, let's go right ahead here now, and we're going to determine the bearing of port Y, and keyword here once again is from. We established that whenever we are measuring a bearing, we're going to measure it at the point that comes after the word from. So we are going to be measuring the bearing from Z, and we're trying to locate Y. So from Z, so Z would have been here. Okay, so once you're going to be measuring a bearing, ladies and gentlemen, you're going to have to establish a north line. So that's why we need a north line here at Z. All right, so we need a north line here at Z. And please bear in mind that a bearing is measured in a, as I said to you here, clockwise direction. So we're going to need to go from the north line here, come all the way around until we meet up into the line that's taking us to Y, because we're measuring the bearing of Y. We're measuring the bearing of Y here from Z. All right, so we're measuring the bearing here of Y from Z. All right, so hopefully you guys have that off and you have that on paper. I'm going to need a little bit of space here. Okay, all right, so we need this bearing. Now clearly you can see that the complete bearing, it has a portion of its angle inside the diagram, and we have a portion of its angle outside the diagram. But once again, you're going to find here that this geometric principle of the alternate angles will play an important role. So you can see that our north line here is parallel to this initial south line that we have. So here, let's see, let's grab this green marker. North line here parallel here to this south line here. So you can see that this 30 degrees come into play. Remember how early we had find it? We never knew that that angle was going to come and play an important role. So here we can see that this angle inside here works out to be 30 degrees. So all we need now is this piece of angle in here, and we can add it to 30 degrees to find the complete bearing. So we can actually find this angle inside here by using any one of our trig ratios, because we're dealing with a right angled triangle. Now let's just be reminded of what the trig ratios are. We use the acronym SO, CA, TOA, And so if we choose to use the sine ratio, which says that sine theta is equal to the opposite side, this is the angle that we're interested in finding. So this 35 degree becomes our opposite. So let's just write the formula first. So that's opposite over hypotenuse. So the sine of the angle which we're looking for is equal to the angle that's opposite to what we're searching for, which is 35. And the hypotenuse is going to be the side that we had calculated to be 76.5. If we choose to use the cosine ratio, and the reason why we are able to use more than one ratio is because we have more than one side. So that makes it even easier no matter what you use. We have to be careful of what sides you are finding the ratio of. So again, finding the cosine of the angle, the adjacent side here is going to be the side adjacent to the angle we're searching for, which is 68, divided by the hypotenuse, again, is going to be 76.5. And if we decide to use the tangent ratio here, you're going to find here that tangent is opposite over adjacent, which in this case is going to be 35. So that's going to be the tan. Okay, it's going to be the tan of the angle is equal to 35 over the adjacent, which is 68. All right, so I'm just going to be choosing one. I'm just going to be using, since I have a little bit of space here, I'm going to be using the cosine ratio. Let me know in the comment section, guys, what you get if you use the sine ratio or the tangent ratio. Confirm with me if you got the correct answer down in the comment section below. All right, so here we go. We're going to go on our calculators here, and we're going to go ahead and we're going to be dividing 68 here by 76.5. And so we get here that cosine of the angle is equal to 0.888 recurring, right? So we can go right ahead here and find that theta is equal to cos inverse 0.888. So the angle here is going to be, let's say, shift cosine 0.888, and that's 27 degree rounded off, approximately 27 degree. Let's just quickly, since we have the time, we have a few minutes before the hour, so let's go ahead and we can just quickly calculate 35 divided by 68, and we would have gotten here that the tan of the angle is equal to 0.514. So if we proceed here and we say shift tangent 0.514, you're going to find once again that the angle here calculates to be 27 degrees. And quickly here, that's 35 divided by 76.5. You're going to find here that the sine of the angle is equal to 0.457. So therefore, if we press shift sine 0.457, once again you find that the angle is approximately equal to 27 degrees. All right, so theta is equal to 27 degrees, and here. Okay, all right, so very interesting question. It really took a turn because, as you can see here, naturally I would have expected to be using the cosine rule, but it turns out that because the angle between the two sides worked out to be 90, it sends us a different direction. So quite a very interesting question here that pops up. So let me know in the comment section, guys. Leave me a like, leave me some suggestions down below. Let me know. I have a few more questions here for you. That is one example 3 and example 4. Let me see if I have another example. I have a quite interesting one around here. That's example 5 and 6. All right, including some angles of elevation and depression. That is also a tutorial that I also need to do for you, because that concept there is going to be vitally important. So look out for that video. All right, guys. So thank you so much for joining this particular tutorial video. I do hope that you appreciate the content, and I hope that you have learned quite a bit from this. So do take care until the next tutorial. Bye bye.